Hello students, today I am coming with a new question, and numerical actually, okay, from chapter number 2. We will see the numerical. Will feel like a new things because you want to find actually the three-dimensional diagonal. Okay, I will come to the question first. The question is, a cube of side B has a charge Q. A cube of side B has a charge Q at each of its vertices. All the time we get the square question, this time it is a cube question. Remember, difference is there. Okay. What is the task here is determine the potential and electric field. Determine the potential and electric field due to this charge array at the center of the cube. You know that you can imagine a cube is a three-dimensional device, yeah, and the diagonal meeting at the center of the cube, that is also three-dimensional. So let me draw one cube first. Square side I am drawing. Remember, in the question they mentioned that side of the cube is B, label we will do. So front side done, all sides are B, and at all vertices there is a charge, so Q is there at all the corner. Now we do the three-dimensional picture of it. Okay. So try your level best how to draw the three-dimensional. Let me try. It's not coming straight. We'll check again. Okay. It will come finally, you don't worry. One or two trial and error, right? So making the cube now. I think okay now. Completed. And complete the other side. Actually, one more side three-dimensional drawing I can do dotted line inside, but not doing now. Okay, not doing now. So from one side it look like a cube now. So what we want to do now is we want to draw the diagonal of it from one corner to opposite corner. Okay, opposite corner through inside, because at that point we want to find the electric potential and the electric field. Okay, can you see the diagonals meeting point? We can do some labeling, like some letter we can use. The O is the letter used to represent the diagonal. Okay, now we start. Before starting, I want to talk something about the calculation of diagonal. Normal Pythagoras theorem you learned, you practiced, you used, correct? Normal. So that is used for a square or for a right angled triangle and all, you can find the hypotenuse. Here you can see the front side there is a square face. So for that face diagonal you can calculate first, just giving an idea or recall we can say. Actual work is not that one here, okay. So face diagonal using Pythagoras theorem on one side, any one side, front side we can consider. Okay, of side they labeled already, it is B is the side. So what is the equation coming is face diagonal is equal to square root of normal Pythagoras theorem you can apply, side square plus side square, yeah. So B square plus B square is equal to 2B square. You know that square root B square we can take B outside, so B root 2. Right now we don't want this one, I just showed how to do it. Okay, actually we required now is space diagonal. I know that this is very brand new to everyone because you are not studied this one. Just Google it to understand more about what is space diagonal. So space diagonal means that inside the diagonal for 3D dimension. Okay, so space diagonal using 3D Pythagoras, space diagonal is equal to square root of B square plus B square plus B square. 3 times will come. So square root of 3B square. This time also B outside, right? Is equal to B square root 3. Okay. Why we calculated this one? Because actually the point O is at half of the diagonal point. Point O is, center point is at a distance half of the diagonal. So we will use that half of the diagonal now. So distance measurement calculating distance between any one of the corner and the center, that is distance between the center of the cube plus what we need actually distance between the center of the cube and each vertex. It will be same, yeah, for all the points it will be same. So R is equal to, what is the actual diagonal divided by 2? So B root 3 divided by 2. Okay, this we will be using for the calculation of potential as well as electric field. Both are okay. So here there are 8 charges at the 8 corners of the cube. So whatever the calculation you are doing for potential, multiplied by 8 will come, because all are identical, right? So here 8 charges, each of value q are present at the 8 vertices. Okay. So let me try. Actually, superposition principle again. Total potential will be equal to potential due to first corner plus second plus third plus fourth plus. But because these are different, these are not different, these are identical. So we don't want to waste our time by writing many times plus plus plus. Instead of that one, what we can do, we can do actually 8 times. Okay, 8 times. So one time we can show like total will be V1 plus V2 plus V3 up to V8. But while writing, it's not mandatory to write every time we write like 1 by 4 pi epsilon 0 q by r plus plus. Instead of that one, we can write 8 into, because identical. There are 8 charges. So 8 into 1 by 4 pi epsilon 0 q divided by distance between the corner and the center. What is that one? B root 3 divided by 2. Yeah. And the time to simplify now. You can see like numerator there is a 8 exists. Denominator there is a 4 exists. Also, there is a 2 also, b root 3 by 2, that will come to the numerator later. Okay, so cancellation finished now. So 8, 2. So 1 by 4 pi epsilon 0, one more time writing, but we will simplify in the next one. Okay, 2q divided by that 4 is actually not required. I will cancel now. That 2 came upside. Okay, from the denominator that came upside. That's why it is showing like that one. So v is equal to pi epsilon 0, that 4 by mistake wrote there. Okay, cancelling now. 1 by pi epsilon 0, numerator 2 into q, that q came from denominator. Okay, 2 into q divided by b root 3 into 2. 1 2 was there already, 8 cancelled that one, other 2 came from denominator. So total 4q divided by root 3 pi epsilon 0 b. So this is the total potential at the center of the cube because of the charge q placed at 8 corners of the cube. If you want to do the calculation for electric potential, you can do the same task, no difference. Same task, no difference. Only one difference is r square will come. Okay, q divided by r square is equation for electric field. That I did not show here, but you can try. Okay, total electric field also you can calculate the same way. Just to change the equation of potential to electric field. Okay, students. Thank you. Have a nice day. Is it clear? A new question, yeah? Level different. Okay, like this, we will go to the different level in next videos. Thank you. Bye-bye.